In the last class, we discussed the basic fundamental terms, that is system, boundary, surroundings, state, equation of state, process, thermodynamic equilibrium, and the continuum model. In continuation with that, today we are going to discuss the zeroth law of thermodynamics. Zeroth law of thermodynamics is one of the four laws of thermodynamics. Interestingly, the zeroth law of thermodynamics was actually developed much later than the original three laws. However, there was some confusion regarding its nomenclature, whether it should be named the fourth law or some other name. The complication arose because the new law, that is zeroth law, gave a much clear definition of the temperature and basically replaced what the other three laws had to state. Therefore, Fowler finally came up with the name, that is zeroth law, to end this conflict. The zeroth law of thermodynamics states that if two bodies are in thermal equilibrium with a separate third body, then the two first bodies are in thermal equilibrium with each other. Say I have A, B, C. If A and C are in thermal equilibrium with each other and A and C are in thermal equilibrium with each other, then B and C are also in thermal equilibrium with each other. This law is based on the temperature measurement. There are various ways to state the zeroth law of thermodynamics. However, in simple terms, it can be said the systems that are in thermal equilibrium exist at the same temperature. Zeroth law of thermodynamics is something worth measuring because it predicts whether the heat will transfer between the objects or not. Even if two objects are not in thermal contact, heat still can flow between them. Whereas zeroth law of thermodynamics states that if systems are in thermal equilibrium, no heat will take place. Now, let us discuss one application of zeroth law of thermodynamics. Consider two cups, say A and B, with the boiling water in it. When the thermometer is placed in cup A, it gets warmed up by the water level. How does thermometer work? There is mercury in it. As temperature increases, mercury expands and we calibrate the height to measure the temperature directly. Now when it is placed in cup A, it gets warmed up by the water until the temperature starts rising. It gets 100 degree, and when it reaches 100 degree, we say thermometer is in equilibrium with beaker A. Now we remove the thermometer from the A beaker and we place it in the beaker B. Again thermometer's height start increasing, टेम्परेचर धीरे धीरे बढ़ रहा है, 100 डिग्री पर जाकर स्टेबल हो जाता है, उसके बाद टेम्परेचर नहीं बढ़ता है. यहाँ से हम कहते हैं कि थर्मामीटर और बीकर बी दे आर इन थर्मल इक्विलिब्रियम विद ईच अदर. But what does the zeroth law of thermodynamics states? By keeping in mind the zeroth law of thermodynamics, we can say that cup A and B are in thermal equilibrium with each other. Thus, zeroth law of thermodynamics states that if system A is in thermal equilibrium with system B in thermal equilibrium C, system A and B are also in thermal equilibrium with each other. And zeroth law of thermodynamics enable us to use thermometer to compare the temperature of two objects. When two objects are in thermal equilibrium with each other, we can say that they are at the same temperature. That is the zeroth law, or the most basic law of thermodynamics.